Ordered pairs of a relation. I'm Anil Kumar, and in this video we are going to understand how can you represent ordered pairs of a relation. Now let me take an example. Let us say our example is that perimeter of a rectangle is, let us say, 32. Now what does it mean? It means that if we draw a rectangle, let's say here is a rectangle, then rectangle will have two set of equal sides. One we call always as length, the other one is the width. So let us say this is length and this is width. So whenever we have a relation, we have to define our variables. So first step is define variables. So in this example, let's define variables as the sides of the rectangle B, width W, and LS length. So we define variables. So that is the first step. So whenever a relation is given to us, try to define variables. In our case, we say L is length and W is width. Okay. Now, relation is perimeter of a rectangle is 32. Now, perimeter is sum of these sides. That means W plus W and length plus L. So, we have the equation as perimeter equals to 2 times length plus 2 times W. Perimeter is given to us as 32. So, we can write this as 32 equals to 2 times length plus 2 times width. If we divide by 2, all the terms, we get 16 equals to length plus width. So we get an equation. Do you understand? So we get an equation from the relation. Now we'll talk about the ordered pairs. So I should say, first step we said whenever you have a relation, define variables, and second is get the equation. Right? So defining variables and find relation. Let me write like that. Find relation as an equation. Okay, so that works. Now once you have an equation, then we can find ordered pairs. Right? Now we can get ordered pairs. That is how we reach ordered pairs. Now what are ordered pairs? Ordered pairs are a set of points which will satisfy your equation. That is what ordered pairs are, right? So let's explore and see how to get these ordered pairs. So the equation for us is that the length plus width is equals to 60. Now what we can do is we can make a table of values, right? So that is one way of finding set of ordered pairs. So I'll use table of values. So that is how we do it, right? So table of values. So in table of values, I'll just select some lengths and some widths, right? So that when you add them, you get 16. So what could be those values? That is what we'll try to figure out. Now if I say that the length is, let us say 1, then width should be 15, right? Only 1 plus 15 is 16. If I say that the length is 10, in that case, width should be 6. And if I say length is 14, width should be 2. So likewise, I can get so many ordered pairs which will satisfy this equation. Right? I can always take length and width as 8 and 8 also, right? And there is no harm. We can select decimal numbers. I can take 8.5 and 7.5. Correct? Now, each of these set of values give us ordered pair which is defined in terms of these two variables. So we can write variables as length and width, and then we'll write the set of ordered pairs in these brackets separated by comma. So we have 115 as one set of ordered pair which satisfies this relation. The other could be 10, 6 and then 14, 2, 8, 8, right? They are in no particular order. We are just selecting few points. That is one way of doing it, right? The other way is that you can graph it also. I mean, uh, we know different values of length and width, right? And we know their sum is 16. So that means that if I take length of 0, for example, in that case width should be 16, correct? So we are taking length here since we have taken it first, and width on this side. So we take 0, we get 16. If I take width as 0, length becomes 16, correct? So that combination gives us set of points which will satisfy this equation. So we can draw a line which represents the relation in the form of a graph where these points are 16 and 16. Now each and every point you can read from the graph. Do you understand? You can read these points from the graph, and these set of points, when written in an order, independent variable first and then the dependent variable, will give you the set of ordered pairs. And as you can see, you can have infinite set of ordered pairs which may satisfy the relation, right? Or sometimes there could be limited number of ordered pairs. But in any case, that is how you find ordered pairs of a relation, right? I hope the steps are clear to you, right? Now for you, let us have a practice question, right? Let's say a question, and that is, we can say difference of two numbers is 24. We say difference of two numbers is 24. So find the ordered pairs which will satisfy this relation, right? The process is same. You can say let the two numbers be x and y, and then x minus y equals to 24. And you can find many different values which will be the set of ordered pairs which will satisfy this relation, because you have found the equation. Equation is x minus y equals to 24. I hope the process is clear, right? So whenever we are talking about ordered pairs of a relation, first set up the relation in the form of an equation by defining the variables, and then identify which variable you will use as independent and which one as dependent. Normally the first variable which you write becomes the independent. There are times when examples which we have taken, it really doesn't matter. You could have written width first and length later, right? But there could be examples like distance traveled with respect to time when a car is moving at a speed of 60 kilometers an hour. Now in that particular case, time will be independent and distance will be dependent variable, right? So at times we do not have a choice. We have to select the right variable as an independent and dependent variable. Well, with this, I hope you got a wide knowledge about ordered pairs. We'll do a few examples and things will be clear to you. Thank you and all the best.